Welcome back to Sleep and Universe. Tonight, we embark on a journey to our neighboring world, a world of rust-colored deserts, towering volcanoes, and ancient mysteries. Tonight, we travel to Mars. Get comfortable, close your eyes, and let your imagination carry you across millions of miles of empty space to the red planet that has captured human curiosity for thousands of years. Pause. Mars, the fourth planet from the Sun, the second smallest planet in our solar system. A cold, dusty world that glows with a distinctive reddish hue in our night sky. The ancient Romans named it after their god of war, inspired by its blood-red appearance. But this color comes not from violence, but from something far more peaceful: iron oxide, rust. The surface of Mars is covered in rusty dust, giving the entire planet its characteristic crimson glow. Mars is our neighbor in the solar system. It orbits the Sun just beyond Earth, taking about 687 Earth days to complete one orbit. A Martian year is almost twice as long as ours, but a Martian day, called a sol, is remarkably similar to our own. It lasts 24 hours and 37 minutes, just slightly longer than an Earth day. This similarity is one reason why Mars has long been considered a potential future home for humanity. The planet is about half the size of Earth. If you could hold Earth in one hand and Mars in the other, Mars would feel like a small, cold twin. Its diameter is roughly 4,200 miles, compared to Earth's 8,000 miles. Despite being smaller, Mars has some of the most extreme geological features in the entire solar system. Features that dwarf anything we have on Earth. Mountains that pierce the sky, canyons that stretch across entire continents. A landscape shaped by forces both ancient and powerful. Mars has two small moons, Phobos and Deimos. Their names mean fear and dread in Greek, fitting companions for the god of war. But these tiny moons are nothing like our own moon. They are irregular, potato-shaped chunks of rock, likely asteroids that were captured by Mars' gravity long ago. Phobos, the larger of the two, is slowly spiraling inward toward Mars. In about 50 million years, it will either crash into the surface or be torn apart by tidal forces, creating a ring around the red planet. The surface of Mars is a geologist's dream, a vast, ancient landscape frozen in time. The most striking feature on Mars is Olympus Mons. This is the largest volcano in the entire solar system. It rises about 16 miles above the Martian surface. That is nearly 3 times the height of Mount Everest. Its base is so wide, roughly 370 miles across, that if you stood on its peak, you would not be able to see the edges. They would lie beyond the horizon. Olympus Mons is a shield volcano, built up over millions of years by countless lava flows. It is so massive because Mars has weaker gravity than Earth, and no tectonic plates to move the surface around. The volcano could simply stay in one place, growing taller and taller, fed by the same hot spot deep underground. Near Olympus Mons lies the Tharsis region, home to several other enormous volcanoes. This volcanic plateau is so massive that its weight has actually distorted the shape of Mars itself. On the opposite side of the planet lies another geological marvel, Valles Marineris, the Great Canyon of Mars. This enormous rift valley stretches more than 2,500 miles across the Martian surface. It is so long that if you placed it on Earth, it would span the entire width of the United States. At its deepest, Valles Marineris plunges nearly 4 miles into the Martian crust. The Grand Canyon would fit comfortably inside it many times over. Scientists believe this canyon formed billions of years ago, as the Tharsis region swelled and bulged, cracking the crust around it. The southern highlands of Mars are ancient and heavily cratered, scarred by billions of years of asteroid and meteor impacts. The northern lowlands are smoother and younger, possibly once covered by an ancient ocean. This dramatic difference between the two hemispheres is called the Martian dichotomy. It is one of the planet's great mysteries. Why is Mars so different from north to south? Scientists are still working to understand. The soil on Mars is toxic. It contains perchlorates, chemicals that would be harmful to most Earth life. But beneath the surface, conditions might be different. Protected from radiation, with possible underground water, the subsurface of Mars might be more hospitable than the barren surface. Mars has an atmosphere, but it is thin and fragile. The atmospheric pressure on the surface is less than 1% of Earth's. If you stood on Mars without a spacesuit, the low pressure would be instantly fatal. The Martian atmosphere is mostly carbon dioxide, about 95%. There is very little oxygen, no breathable air, no protection from the harsh radiation of space. Because the atmosphere is so thin, temperatures on Mars fluctuate wildly. At the equator, on a sunny summer day, temperatures might reach a comfortable 70 degrees Fahrenheit. But at night, they can plummet to minus 100 degrees Fahrenheit or colder. Near the poles, temperatures drop even further. In winter, it gets so cold that carbon dioxide from the atmosphere freezes solid, creating vast polar ice caps of dry ice. In summer, these caps partially sublimate, turning directly from solid to gas without becoming liquid. Beneath the dry ice at the poles lies water ice, real, frozen water. In fact, there is quite a lot of water ice on Mars, hidden beneath the surface and locked in the polar caps. If all the ice at Mars' North Pole were to melt, it could cover the entire planet in a layer of water several feet deep. Mars experiences dust storms. Some are small and localized, others grow to engulf the entire planet. These global dust storms can last for months, blocking out the sun and creating a dim, dusty twilight across the entire world. The dust is fine, like talcum powder, and it gets into everything. It coats solar panels, clogs machinery, and creates challenges for robotic explorers. But it also creates spectacular phenomena. Dust devils, towering whirlwinds that dance across the Martian plains. Crimson sunsets, where the dust in the atmosphere scatters light, making the sun appear blue. Yes, on Mars, sunsets are blue. The dust particles scatter light differently than Earth's atmosphere does. So as the sun sets on the red planet, it bathes the landscape in an eerie blue glow. The Martian day-night cycle is similar to Earth's, but the seasons are longer because Mars takes longer to orbit the sun. A Martian year has 687 Earth days, so each season lasts about twice as long as the seasons we experience. The tilt of Mars's axis is also similar to Earth's, which is why Mars has seasons at all. In summer, one pole tilts toward the sun and warms. In winter, it tilts away and freezes. For centuries, humans have wondered if life exists on Mars. Today, we know that Mars is a harsh, radiation-soaked desert. But it was not always this way. Billions of years ago, Mars was very different. Evidence suggests that ancient Mars had a thicker atmosphere, warmer temperatures, and liquid water flowing on its surface. Rivers carved channels through the landscape, Lakes filled ancient craters. There may even have been a vast ocean covering much of the northern hemisphere. Robotic missions have found dried-up river valleys, lake beds, and minerals that only form in the presence of water. Mars was once a wet world, possibly not so different from early Earth. But something changed. Mars lost its magnetic field. Without this protective shield, the solar wind, a stream of charged particles from the sun, slowly stripped away the Martian atmosphere. As the air thinned, the water evaporated or froze. The rivers stopped flowing. The lakes dried up. Mars became the cold desert we see today. But not all the water disappeared. Some remains locked in ice at the poles and buried beneath the surface. In recent years, scientists have discovered what appear to be seasonal flows of briny water on some Martian slopes. Salty, liquid water flowing during the warmest months. If there is water, even harsh, salty water, could there be life? Scientists are searching for signs of past or present microbial life on Mars. They are looking in places where water once flowed. They are drilling into rocks, analyzing soil, searching for organic molecules, the building blocks of life. So far, we have found no definitive evidence of life on Mars, but the search continues. The Perseverance rover is collecting samples that will one day be returned to Earth for detailed analysis. Those samples might hold the answer. Even if Mars is lifeless today, it might have harbored life in the distant past, when it was warmer and wetter. Finding evidence of ancient Martian life, even extinct microbes, would be one of the most profound discoveries in human history. It would mean that life arose independently on two different worlds in the same solar system. And if life arose twice in one solar system, it suggests that life might be common throughout the universe. Humanity's fascination with Mars stretches back thousands of years. Ancient civilizations tracked its motion across the sky. Early astronomers peered at it through primitive telescopes. In the 19th century, some astronomers believed they saw straight lines crisscrossing the Martian surface. They called them canals and speculated that they might be built by an advanced Martian civilization. This sparked decades of speculation about intelligent life on Mars. We now know those canals were optical illusions. But the dream of Mars persisted. The space age brought our first real glimpse of the red planet. In 1965, NASA's Mariner 4 flew past Mars and sent back the first close-up images. They revealed a cratered, lifeless world, shattering romantic notions of a vibrant Martian civilization. But the exploration had just begun. In 1976, the Viking landers touched down on Mars, the first successful landings on the Red Planet. They tested the soil for signs of life. The results were intriguing but inconclusive. Decades later, in 1997, a small rover named Sojourner rolled across the Martian surface. It was no bigger than a microwave oven, but it proved that mobile exploration of Mars was possible. Then came the twin rovers, Spirit and Opportunity, landing in 2004. Designed to last 90 days, Opportunity continued exploring for an astonishing 15 years. It found compelling evidence that water once flowed freely on Mars. In 2012, the Curiosity rover landed in Gale Crater. The size of a small car, Curiosity is a mobile laboratory equipped with cameras, drills, and scientific instruments. It has been exploring the base of Mount Sharp, a mountain of layered sediments that holds clues to Mars's ancient climate. And in 2021, Perseverance joined Curiosity on the surface. This rover is searching for signs of ancient life and collecting samples for future return to Earth. Accompanying Perseverance is Ingenuity, a small helicopter that became the first aircraft to fly on another planet. These robotic explorers are our eyes and hands on Mars. They traverse alien landscapes, analyze rocks, and send back stunning images. They prepare the way for the next chapter of Mars exploration, human exploration. Mars is the most Earth-like planet in our solar system. It is the most accessible world beyond our own, and it may be humanity's first step toward becoming a multi-planetary species. Space agencies around the world are planning human missions to Mars. NASA's Artemis program aims to return humans to the Moon as a stepping stone to Mars. Private companies like SpaceX are developing powerful rockets designed to carry people to the Red Planet. The challenges are immense. A journey to Mars would take 6 to 9 months one way. Astronauts would face radiation exposure, muscle and bone loss from low gravity, and psychological challenges from isolation and confinement. Once on Mars, they would need to produce their own water, oxygen, and food. They would need to build shelters that protect against radiation and extreme temperatures. They would be millions of miles from help if anything went wrong. But despite these challenges, the dream persists. Imagine a future where humans walk on Mars, where settlements grow beneath protective domes, where explorers climb Olympus Mons and descend into Valles Marineris. Mars could become a backup for humanity, a second home if anything ever happens to Earth. It could become a laboratory for studying life's origins, a testing ground for technologies, a source of resources. Terraforming Mars, transforming it into a more Earth-like world, has been proposed. It would take centuries or millennia and technologies we do not yet possess, but it captures the human imagination, the dream of making Mars bloom. For now, Mars remains a cold, distant desert. But it is a desert we are learning to understand, a world we are beginning to explore, and perhaps one day, a world we will call home. Pause. As we conclude our journey to the Red Planet, let your mind rest among the rust-colored dunes and ancient valleys of Mars. Let the mysteries of this neighboring world carry you gently into peaceful sleep. Thank you for traveling through space with me tonight. Sweet dreams, and may you dream of distant horizons. Until next time, this is Sleep and Universe.